Hello everyone. Let's start with our another system design problem, and this is a very popular question. Design a parking lot. That's all the interview will give you. So let's get started. Step one would be to ask your questions and set on a particular requirement and also state your assumptions. So when you hear this problem, that design a parking lot, first thing you should ask is that uh, whatever questions is coming to your mind regarding the parking lot system. So ask that will there be multiple floors or just a single floor, multiple levels of parking. All right. So in this, uh, the interviewer might say that yes, we will have multiple levels of parking. Then another question would be to ask whether what types of vehicles will the parking lot accommodate. So the interviewer might answer something like car, bike, and truck. Another uh, a question to ask would be all the parking spots wouldn't be of same size. So parking spots can be of different sizes, small, medium, large. Okay. And another thing to ask is that will there be a parking fee? Do you want me to handle the money aspect of the parking lot? To which your interview might say that no, for now, let's design something easy for now. Okay. And you can ask like questions about time limit or whatever, to which your interviewer might say no. Another question which can come to your mind, and it's important that you state your assumptions here. So you can say something like that for now, you can you can restate what you want to design. For example, that a parking lot will have several floors and each floor will have several spots. Each spot can be of different type, and in a spot a vehicle can be present or cannot be present. Another question which you might want to ask is that how will the vehicles be assigned? Uh, so to which your interviewer might say, might leave it to you to whatever design you want. So for example, let's say that a bike goes in. So a bike can occupy a small spot, medium spot, or large spot, or do you want me to put bike always in small spot, and if all small spots are done we can put it in medium, and so on. To which your interviewer might say that suit yourself, or whatever you think should be done, do that. All right. So I think for now these requirements are okay. uh, Then the next step should be for you to state your uh, entities. So for this, you might want to, another step will be to state your entities. So what entities can you think of at the moment? So one entity which I can think is definitely vehicles. uh, Vehicle can be a class because vehicle are of different type, and each vehicle will have a unique number, uh, and so on. Another thing, as we stated, that we will have a parking spot, and in your design, it's always beneficial if you think bottom up, which means that you want your smaller entities to list first, and then you can move on to bigger entities. So we have a vehicle. Vehicle will be in what? In a parking lot, in a parking spot. Another entity can be floors, because your parking spot is where? In the floor, and it's a multi-level parking. It's a multi-level parking lot, so it will have multiple floors. And I think the main entity will be your parking lot. So, and also while you are listing this, it's also important to list why you need this particular class, to state what you need from it. So you can say something like I need vehicle because I want it to contain information about the vehicle, and uh, Then for parking spot, you can say that we want a parking spot who should tell us whether the parking spot is occupied or not occupied, and if it is occupied, then by which vehicle. Uh, a floor will have many parking spots, so it is responsible for collection of its spots in the floor. And uh, finally, the parking lot will have multiple floors, so it needs to keep track of the floors, right? So it's always better before you start coding to tell the interviewer what you want to exactly code here. And then while coding also, you shouldn't be silent. You should speak all the time why you are making a certain function, or what members will be there, and then why do you need that, so on. It will get clearer as we code. So okay, first thing which comes to my mind is that we want a vehicle can be of various types. It can be car, bike, truck, and so can be a spot type. So it is better for now to create enums. Another thing which you can do here is that you can have separate class, make your vehicle class an abstract class, and then you can have individual classes of car, bike, and truck, which will who will be child classes of your vehicle class. But I think that it's sort of unnecessary for now, although it's a design decision. You can even if you go with that, I don't think so your interviewer will penalize you or will penalize me here. Either one is fine. For now, I'm just stating an enum, and I will list my vehicle types here. Okay, and another enum I think will be for my spot type. So spot again are of different types, and over here we have stated small. Let me capitalize everything. Small, medium, medium, and large. Okay, so far so good. And it's better if you keep on asking your interviewer if he is getting what you're writing. So it's better for your interviewer to be in the same page as you are. So keep on asking that, does this make sense, or am I clear till now? Things like this. Next thing which you should follow your entities which you have listed. So I have listed vehicle, and as I told that it will have the details about the vehicle. So vehicle will definitely have a vehicle type. It will be of a certain type. Vehicle type, and a vehicle type, let's name it as type. And what else is there in a number in a vehicle? It has a license number, or yeah, as you can say number, whatever. This will be so by default in C++, every member, whatever you declare, is private unless you explicitly state it as public. So these are definitely my private members. Now for the public, I would want a constructor to be there. So as part of my constructor, I'll be passing the number and the vehicle type T. And then over here we can have number to be num. So whatever value goes in num will be assigned to number, and type as T. Okay. And what else can be here? So we can have getters for these two. So let me quickly write vehicle type, get type, which will be my return type. So this will basically give me, I don't want my other class to directly access my private numbers of this class. So which is why we have getters usually, which is public. So other class can refer to this function by an instance of the vehicle object. Okay, so far it looks good. Now let's move on to the next class. Next class is parking spot. So parking spot. Alright, so my parking spot, what will a parking spot consist of? What did we say? A parking spot will definitely have a spot type. So spot type, which will be, let's name it type. And what else? It will have a certain identifier, so let's name it as ID. And then it can have a vehicle, right? So in a parking spot there might be a vehicle, so we will use a reference to vehicle. Let's name it as vehicle. Okay, and also a parking spot can be empty, cannot be empty, so we need this occupied thing, occupied boolean. Okay, so now for the constructor of this, so whenever we are declaring a parking spot, whenever we are making it, we know that there will be, it will be of a certain type, which we know. Let's name it as T here. It will have an ID also, and I think that's all, because initially every parking spot will be empty. So type will be equal to T as we passed, ID will be equal to ID as we passed, and vehicle will basically, it's empty, so vehicle will be null, the pointer will be pointing to null, and occupied will be false. Okay, good. So now we can have another function to tell us whether it is available or not. So is available. Now this function will basically return the not value of occupied. So if the occupied is true, then it means that another vehicle cannot enter. If occupied is false, then it means that it is empty. So this should return true because it is available for a vehicle to park. Okay, sounds good. Now the main function of this class will be to determine if our vehicle can fit or not. So this function will take a vehicle object, reference to a vehicle object, and then, as I said, when can a vehicle be fit? That's up to you, whatever logic you want to write. But I am going to basically write something like, if the vehicle is a smaller one, let's say it's a bike, then it can fit in any spot type, either it's small, medium, or large. If it is car, then it should only fit in medium and large, and if it's a truck, it should only fit in large. So if we have already written the function get type. So if this get type is returning as bike, so vehicle type and bike here, then we know that this vehicle can fit in every spot. So it can fit in a spot, right? If whatever its type is, regardless. Let me copy this. If my vehicle type is basically a car, then it will only fit. So I can write, maybe, yeah, I can write another if condition. If it is a car, and if my type is equal to, this type is basically the type of my spot type. So if this type is equal to what is it, medium, or my type is equal to large, so only in these cases it will return true. And if it's a truck, if it is a truck. Let me wrap it in if. And type is equal to my large. Only then it should return true. Return true. Else in other cases it returns false. So clear till here? Why we made this function? To determine whether a vehicle can fit in this parking spot or not, and it should be the responsibility of the parking spot. That is why we are writing this function in this class. And another function should be that we should write if a vehicle, whenever we are parking, we should modify its occupied flag to false, to true, stating that a vehicle is present, and also we will assign a vehicle, right? So let's write that function. A park will have a vehicle object reference, and it's basically that when can a park take place? If it is available, if is available is we don't even need to write it here. We'll instead just write our vehicle to be pointing to this V, and our occupied to be set as true. Okay, and I think it should be a void, and we should also have a unpark. So unpark, what should it do? Basically, vehicle should be null and occupied should be set to false, again stating that this position is now open to other vehicles. Okay, till here any doubts? So you also need to engage your interviewer from time to time, so that it's not the only one which you are only you who is not speaking. Okay, now for the next class, it is floor. Okay, so class floor. So a floor will have many parking spots, and a floor will have a number for sure. So int id number, whatever, and this will have a vector of parking spots. Parking spots. Okay, sounds good. Now in the constructor, what do we want? Basically, it will just initialize. It will have the ID. So ID of the floor number, and that's all. Now there should be a function to add a parking spot. So add spot. It will take a parking spot reference, and simply it should be spots dot push back and spot. All right. Another so there should be a function in the floor itself which should be of the type parking spot. I mean, the return type should be parking spot, because it should be the floor's responsibility to find a parking spot for the vehicle, and then it should be the parking spot's responsibility to determine whether it can fit or not, right? So parking spot object, and then it should be the responsibility should be of finding the spot, and this vehicle object should be passed. It should, I mean, it's up to you. Either you can have separate vectors for different kinds of spots, like separate vector for small spots, separate for medium, and separate for large, and then based on the vehicle you're iterating on those spots first and then the other. But just to make the thing simple here, we can simply write it that, or else you'll also talk to your interviewer about this and you would ask him which method do you want him to build, does he want you to build. So here simply I think this should work. So if this spot is available and my vehicle, sorry, my spot, it's a can fit this vehicle V, then we can say that okay, this spot looks good and we will return spot. Else, if we are not finding any, we'll return null, stating that this floor is full, or yeah, it cannot, this floor cannot accommodate the vehicle. That's all I think for this class. And our main class will be, the orchestrator of the class will be our parking lot. What should be the responsibility of parking lot? A parking lot will have many floors, as we stated. So it should have vector floor object floors. Cool. And then in the public, there should be a function to add a floor, which is simple. You basically pass a reference to floor, and then over here floors dot push back floor. Another function, the main important function is to park the vehicle. Okay, so this will again return a parking spot. Parking spot park vehicle, which will take vehicle argument. And over here, what you will do is you will iterate in the floors. So for auto floor of floors, then you basically have a parking spot object, name it spot, and you are basically calling this function which you wrote above. So floor and then find spot. So for every floor, it will check whether a spot is available. It is filling the floor one by one. So if it is available, then we pass in the vehicle object. If it is available, it should return something. So if my spot exists, if it is returning a spot, and if my spot can park this vehicle, which we have already written, this function spot park, and then we'll also pass the vehicle. Then we return this spot object. Else we return null. Okay, and another function will be to unpark the vehicle. So void unpark vehicle. Over here, so unparking vehicle will have this parking spot object, and it basically is park dot unpark, which we have already written here. So the vehicle should be null, and eventually are occupied should be true. Okay, so this is the entire design of a system, uh, and this is you can do a dry run, so you can like sort of explain the interviewer that let's say that there's a parking lot. At first we'll add the floors, so we'll make a new floor, and then in a floor we will add the parking spots, and then we will add that particular floor in our parking lot, and then once a new vehicle is there, we will call the park vehicle object, a park vehicle function uh, in our parking lot, and then basically we can, yeah, that's how we work the park and unpark vehicle functions. So I hope things are clear here. uh, there can be multiple questions, multiple follow-ups which your interviewer might ask, for example to you, for you to uh, have a payment thing maybe, or to improve this logic of fine of only bike should be first given preference to compact spots, small spots, and then later. So you can do those optimizations if you want. And yeah, I think payment is required. Then we might want to have a ticket class also. A ticket class will basically have to make keep track of the entry time of the vehicle, uh, and you can also ask the interviewer if he wants you to then you can tell about the fee strategy design pattern, also strategy design pattern, in which you there can be multiple strategies of charging a particular vehicle and so on. uh, but I think this is a very simple design. We can make another follow up in this, but whatever follow ups are there that you can surely do, depends on what your interviewer exactly wants you to have. Keep having those conversations, and I think you'll be good. Thank you.